Hi guys, today we're going to do an energy checklist. So all the equations we've learnt so far, we're just going to have a recap on them. So let's start with kinetic energy over here. Kinetic energy is energy due to motion and movement. So over here you can see someone that's running along and they've got kinetic energy. And it's given by this equation here, E is equal to a half mv squared. Now m in this equation is the mass, and mass has units kilograms. V is the speed, and speed has units meters per second. E is the energy, and that has units joules, denoted by a capital J here. Okay, let's move on to elastic energy. Elastic energy is energy due to compression and stretching. So you'll more likely see it with springs and elastic bands. Now, elastic energy has this equation, E is equal to a half Ke squared. Now K is the spring constant, and this has units newtons per meter. Now the spring constant is fundamental to the material itself. It depends material to material. Okay, E is the extension, and that's measured in meters. If you consider this spring here as the initial position because no mass is attached, and you consider this as the final position because mass has been attached and the spring has stretched. So the distance from the initial position, E, is what the extension is, and that's what you put into your equation here. Now capital E is the energy, and that's given in joules, denoted by a capital J. So that's elastic energy. Let's move on to gravitational potential energy. Gravitational potential energy is energy due to things being a distance above the ground, so facing the attraction of gravity. And it's given by this equation here, E is equal to mgh. M is the mass, and that has units kilograms, like here. Remember, it's kilograms, not grams. 1 kilogram is 1,000 grams. That's important to note. G is the gravity, and that has units newtons per kilogram or meters per second squared. In our GCSEs, gravity is normally known to be 10 newtons per kilogram. Height, h, has units meters, and that is, for example, in this diagram here, is the distance from here to here. And energy, E, has units joules. So in this diagram here, you'll note that the yellow ball has quite a lot of gravitational potential energy because it's a high distance off the ground. But the blue ball here has its gravitational potential energy lowering, but its kinetic energy increasing because it's moving at a higher speed. And you can see that the red ball has hardly any gravitational potential energy because it's not a distance above the ground. Okay, let's move on to thermal energy. Now, thermal energy is the most tricky out of all of them, I think. It's given by this equation here. Delta E is equal to mc delta theta. Now, these deltas mean a change in. So that means a change in energy equals the mass times the specific heat capacity multiplied by the change in temperature. Now, m, let's start off with the easy one. M is the mass, and that has units kilograms. Specific heat capacity has units joules per kilogram per Celsius. Well, not per, kilograms times Celsius, all divided by joules. This is a kind of tricky unit to remember, but it's always good to remember. And then you have the change in temperature, which is in Celsius. So one way to remember the units for specific heat is that it involves the units for energy, the units for mass, and the units for Celsius. I want to stop and ask you a question now. What is the specific heat capacity? Okay, hopefully you guys have all figured it out. The specific heat capacity is the amount of heat required to raise 1 kilogram of mass by 1 degree Celsius. So again, it is the amount of heat required to raise 1 kilogram of mass by 1 degree Celsius. Okay, amazing. Let's move on to power. Now, power is important because it relates energy to time, and it's just quite an important equation to remember for your GCSEs because a lot of questions come up on power. So first of all, let's define what power is. It is the rate of energy transfer. From that, we know that it's going to involve time because it has rate in the definition. So the equation for power is energy transferred, E, divided by time taken, T. And power has units watts or joules per second. You can see where the joules per second comes from because it's just a joule divided by a second, like it is here, and that is a unit for power. But more commonly, you'll see it known to be a watt. Okay, I want you guys to pause the video and try and work out this question. So you have a lady with a mass 65 kilograms. She moves a height 0.4 meters when she does one chin-up. It takes her 5 seconds to do one chin-up. I want you to work out the power using this equation and all the other ones, trying to use one of all of these. Okay, hopefully you've unpaused the video now and you would have used the power here and this equation here because, right, we have a mass, which we don't have here, but we have a mass here, here, and here. We've got a height, which we don't have here, and we don't have here. We have here, so we know that it's going to be gravitational potential energy. Also, the fact that she's moving off the ground. We need to find out what G is. We know what G is. We know that it's 10 newtons per kilogram. So if we have 65 for the mass, so 65 times gravity multiplied by the height, 0.4, that should give us the energy transferred. So 260 is the energy transferred, divided by the time taken for the transfer, which is 5 seconds, and you should get 52 watts. So I want you guys to try it out. You'll be given this sheet to sort of remember and use it for revision if you want to. I've printed them all out in colour, so yeah. Thank you for taking the time out of your day to watch my video, and I hope it helps for revision. Bye!